All right. Hey, everybody. This is Carl from Smallstep. I'm here with Hunter Hawk. Um, you want to do a quick intros?
Yeah,
So my role is a senior staff engineer, special projects, and Hunter.
and I'm our security solutions architect. We've been here numerous years now working on PKI and now device identity.
Yeah. Yeah, it's good to be here today. So we're going to talk about Wi-Fi, and we have. I'll give a little background, then we have a presentation we can go through, and then Hunter's going to do a demo, and we can do some Q&A along the way. Um, so. Um, to sort of set the stage for this, I want to talk about kind of four different levels of enterprise Wi-Fi and kind of how people are approaching it today. Um, I would say at level one, in terms of like security, is just cafe Wi-Fi, right? Like you just have a Wi-Fi network with a name and a password, and everybody has the password. And it's simple in a way, and it also, in a weird way, it's kind of zero trust because like you're not trusting the network perimeter here. You you just assume that the network is compromised, and everything else that runs on it has to be encrypted and secured in other ways. But like ultimately, it's not that great.
I say that's pretty
It's not that
generous,
great to be
calling it zero
running.
trust.
You don't want to be passing pieces of paper around with passwords on it to everybody. I mean, it's just like it's yeah, not great. But it works up to a certain size, I guess. And then sort of the next level would be like at a certain size organization start using MDM and using things like Jamf or Intune to enroll devices and then send down configuration to those devices. And and now we're getting into sort of like, um, you probably have a little IT department, and the sort of first level here is you can do the same thing. You could do a network name and password and send that down as an MDM profile, and that totally works. And what's nice about that is that it is like the first level of like auto configuration so that people aren't having to pass passwords around. The IT administrator is like setting it up, deploying, these configurations to all the endpoints, and then, people just open up their laptop and the Wi-Fi just works. They don't have to think about the password. But, it's a shared secret, and anybody with a password can still connect to the network. And then the sort of level three for, Wi-Fi security would be to start using certificates and using EAP-TLS, which is today it's like WPA3 Enterprise. EAP-TLS is kind of um, the gold standard for certificate-based Wi-Fi access, using client certificates on all the machines. So now you have some more complexity because you have to get client certificates to all those machines. Um, but it is using TLS to authenticate the connection. It is much more high security than a password, and very difficult to break into these networks, I think. And the certificate, the way that this has been done for years is that the certificate is issued to these devices using a protocol called SCEP, SCEP. And SCEP is it's like 20 years old or something. I mean, it's a way of issuing certificates to devices that has been used in a lot of different contexts for a really long time. Um, and one of the big downsides of SCEP is that it still uses a shared secret. So issuing certificates to these devices, the SCEP server, the certificate authority, essentially has if you have the right password, you can get a certificate from that CA. And uh, it, there is still no, in a sense, it's not that different from cafe Wi-Fi because anyone with that shared secret can issue a certificate and get on the Wi-Fi still. And so you don't have a sense of like it's harder. It's you can deploy these certificates with MDM. It's sort of harder to get the shared secret. Um, but and there are some ways around this. There's dynamic secrets where they only last for 5 minutes, and there's sort of advancements that have been made over the years to make SCEP a bit more secure. Um, and uh, I would call that like level three, and that's kind of how most people do enterprise Wi-Fi today. I would say that's the standard pretty much for most organizations, most large organizations. And then the kind of level four would be using ACME device attestation. And this is where, yeah, the device identity stuff comes in. And I'm going to hand it off to Hunter to start getting into that.
Thanks, Carl. So high level, Smallstep can help enable this final level ACME device attestation. So we have been working with Google the last handful of years to extend the ACME protocol made by Let's Encrypt back in 2016. So 16 years newer than SCEP for web-based certificate issuance. So traditionally, they would give you a string, you'd pop it into a text record in DNS, and then when that resolves for the domain registrar, you've proven that you own the domain or at least have access to the domain. So out of that, as a replacement for SCEP, we collaborated to add a new challenge type to the protocol. So what I described was the the DNS01 challenge type. We added the device attest01 challenge type, which means if we are given an inventory of all of the public keys for the EK pub keys is what we call them for the TPMs that we trust, we can encrypt the challenge when we send it down to the device, do that cryptographic exchange with the TPM or secure enclave in the case of macOS. And out of that, we're doing a mathematic proof, assuring that the device connecting has a piece of hardware in it before we authenticate the device and issue the certificate down. So the benefit there is that we are strongly authenticating the device during issuance, but also the certificate and key land back in the TPM, where it's bound to the device, non-exportable, non-exfiltratable, and realistically, anywhere that you use that certificate becomes unphishable because the device becomes an implicit second factor in the flow. So as opposed to what Carl was describing with SCEP, this is not only much newer, but solves virtually all of the security gaps that exist today in your average IT Wi-Fi network. So plugging this back into the Wi-Fi conversation, our goal as an organization is to help you enforce device identity for everything, including Wi-Fi. So Wi-Fi tends to be the best lowest hanging fruit. Everybody's users probably use Wi-Fi, assuming you have an office. And so this tends to be our number one starting point with a given client. And so from there, we can move outwards from Wi-Fi to things like hardware-backed SSH, certificates for VPN and ZTNA solutions, etc. My favorite personal one is for second factors to identity providers. Say Okta has a compromise. We help mitigate against that as well. But there are four key components to achieving this like level 4 security that Carl and I are talking about. So to do ACME device attestation, we need number one, an inventory of all the public keys of all the devices that we trust, because otherwise we can't strongly authenticate them. We need to be able to say, these are the 3,085 devices that we have under management that we know of, and only these 3,085 devices can connect to Wi-Fi. It's no,
And
please.
yeah, and when you say public key, you're talking about it could be in the TPM, the endorsement key, which is a public key, or in like a secure enclave on an Apple device. Um, yeah, so there's different kinds of keys, but they're essentially it's the same technology across no matter
Mm-hmm.
what kind of device it is.
Good call out, Carl. Yeah, this applies to any cryptographic coprocessor, um, regardless of operating system type. From there, once we have the EK or AK pub keys in the case of like secure enclave, We can then use Smallstep's core PKI functionality to issue these ACME certificates back down to the TPMs. So from there, we provide a configuration layer where we can either plug into MDM and function as certificates in there in an automated fashion. That works beautifully, say, with Jamf and macOS, which I'm going to demo today, because the ACME protocol is supported natively in the Apple ecosystem. And so iOS, macOS, I'm not sure about tvOS, they all support, thank you, Carl, they all support ACME device attestation natively. And so if you're running an MDM like Jamf or Mosel that supports the challenge type, you can just push that down. It'll do the attestation against Apple's attestation authority, and from there, issue the cert. To get this to work on additional operating systems, so think Windows, Linux, or Chrome OS, we've developed an agent, which I use loosely. It's a Golang binary, runs as a system daemon that can plug into the TPM module on those devices. So that is required in order to do that attestation. And from there, we can also use that tooling to automatically connect you to Wi-Fi. So much better user experience, lower IT support burden. And from there, enforcement comes from the Radius server in our instance today. Carl,
What's an
anything I missed on that
attestation?
spiel? I was going to say an
Yeah, what's an
attestation.
attestation? Go ahead, sorry.
Yeah, no. So that's the device cryptographically proving its device via man, this sounds better in my head than it does in like out loud, right? So we are doing a cryptographic proof that we have a piece of hardware inside of the device. And
Yeah,
so
so
if
down to a
we,
unique piece of hardware. And
yeah,
whether it's an Apple device or the manufacturer, the TPM, right? That's the root of trust. It's a hardware manufacturer root of trust in this case.
perfect. And so, as I was hinting at, Smallstep device identity sits on top of, like, this is our platform. It sits on top of our core inventory features, our PKI functionality. We can scale PKI up and down for you for given really any use case. Um, but from here, just touching on a Smallstep agent plugin, I mentioned that we are ubiquitously supported in the Apple ecosystem. We've added support for um, Linux, Windows, Chrome OS, and soon to be Android as well via the agent. So this will just be a PKCS11 connector for the TPM in order for the client to kick off that request for an ACME certificate and start that attestation. On the enforcement side, something that ETLS requires is radius authentication. To do that, you need to run an external like radius provider outside of your wireless access points. So chances are it might be Cisco ICE, Juniper Mist, NPS, all of which are commercial enterprise radius solutions, which are great. We can integrate directly into those if you like that solution. Alternatively, we do provide an enterprise radius server to you as part of the product. And so this would be cloud hosted. We can scale this out to run them in any GCP region in the world. So we can scale them out to be low latency. And from there, it plugs in natively to the Smallstep ecosystem. So much lower barrier to entry. You can just stand it up and start running with Smallstep via our radius provider if you need one. I'm kind of getting into the nitty gritty of radius. I'm going to turn this over to Carl.
Yeah, yeah, so let's talk about how radius authentication works with ETLS. Um, this is assuming that everything's kind of already been set up, right? And we're running an ETLS enterprise Wi-Fi network. And what's interesting here, the endpoint on the left here, the laptop needs to trust whatever certificate authority the Radius server certificate is has a certificate from, right? And so that it can complete the chain when it starts talking to the Radius server, it can complete the certificate chain, and it knows that it's talking to a the trusted Radius server. Because there are certain kinds of attacks there you can masquerade as the Radius server and cause all kinds of trouble. Um, and then on the side of the Radius server on the right, this is where the server needs to check the client's certificate against a what we call it an account CA that is basically making sure that this is one of the devices that we trust to join the network. And the interesting thing about this workflow is that the the access point, the Wi-Fi access point with Radius, it actually doesn't do anything but proxy the connection at the beginning. It's not handling the TLS handshake. It's just proxying between the endpoint and the Radius server. And the TLS, there's a TLS handshake that happens between those two devices. And then if that handshake is successful, it's mutual TLS, so both sides need a certificate. And if all the certificates are checking out and everything routes back to trusted, roots on both sides, then the Radius server um, it has a shared secret with the access point, and it will basically say, okay, yes, this device is approved to join the network,
Mhm.
and then the access point allows the device on. These protocols are like they've been around for a long time, and one of the things about that's not really shown here is that this whole handshake, that the whole flow here is not encrypted, right? This is just going over the wire between, especially between the Radius server and the access point where the connection gets approved. And so there is a newer, I don't know how much newer it is, but there's a newer sort of fix for this, which is called RADSec, and it adds security to especially this sort of step 2 and 3 part of the connection, so that you have encrypted traffic between the Wi-Fi access point and the Radius server. And we offer that as part of our enterprise Radius offering as well. Let's see, did I miss anything here? I think that was pretty much covered the
Yeah,
whole flow.
you nailed it. Curious, what are some other features that our Radius providers have outside of just authenticating? Is this a certificate that we trust?
Yeah. So we authenticate the certificate, which will check against, your device inventory, right? If you're using Acme device attestation, you're going to have an inventory of devices. We're going to make sure that that only the devices in your inventory can connect to the network. And that's kind of like the biggest feature of this whole thing, because those keys are hardware bound, as Hunter was saying, and there's just you can't exfiltrate the keys from these laptops. You're not going to have devices joining your network that aren't already in your inventory. So that's kind of the biggest feature. For our Radius setup, we also have like webhooks, reply attributes. If you need to do like put devices on certain VLANs, you can do that. The webhooks are nice because you can add things like I want a webhook when a device connects that's going to make sure that that device is also passing posture checks, right?
Hmm.
That's a great feature as well that we offer. And then we also have geo-distributed radius. So we can deploy radius servers anywhere in the world. If you have a network that covers multiple regions, we got you.
Thanks, Carl. I noticed you didn't say MAC address filtering.
Hmm. MAC address. Is that something we do?
No, we don't.
We don't need to.
No, because we're checking the
Yeah,
certificates. Yeah.
exactly.
And that would just open,
Yeah,
a
it's
potential threat vector because
yeah.
anybody can spoof a MAC address.
Yeah, MAC addresses don't matter anymore. They're nominal identifiers that were they never really identified devices before, but now that we have these device certificates, definitely don't need to like think about MAC addresses anymore.
On just to speak to the simplicity of that threat vector, one of our biggest customers is using like one of their users is using us in his home lab at home because his kids kept spoofing their MAC addresses on their computers. And so
I love that.
I know, right? So this is
It's
his
funny.
solution. He's like, no, this is this device.
Yeah.
Um,
I mean, I think like teenagers make some of the best security pen testers sometimes.
yeah, for real though. So I thought that was kind of fun. By the way, everybody, I forgot to make a call out at the beginning here. We do have a Q&A button here in the chat. So if you have any questions, please send them
Yeah, feel
over.
free.
Carl's going to be watching probably a little bit better than I will. but we can go ahead and get those answered as they come through. Cool. So let me get into a bit of a demo. What I'm about to walk through is walking through like an inventory of my devices in my trust inventory, noting this is a trust inventory, not necessarily a device inventory. Key difference being this is all of the public key data for the TPMs that we trust. So not necessarily need to be in MDM, but we need them in a trust inventory to do that attestation. Likewise, some radius configuration on our Smallstep account so we can do policy-based access to given resources. So I have that set up in Smallstep, and then we'll walk through like what it takes to set up from an admin's perspective on the router and in MDM to support the flows. So just don't want Jamf to time out on me. Clicking into the Smallstep dashboard, this is our device identity platform. And again, any questions that come up, please drop them in chat here. I'm going to be skating over several features, just focusing on Wi-Fi, but happy to answer any questions. But in here, I have a device inventory and then resources that I'm protecting. And so here I have them pulling over from Intune, from Jamf, and then I have a handful that are manually enrolled via the API. So MDM is just one integration point. We support Jamf, Intune, Workspace ONE, and several more that I just can't think of off the top of my head. But for devices that aren't under management, we have user side flows with a required approval step. And if you have an inventory of all these EK pub keys, we can just burst them in using our API and run the agent. So let me click into that. For the devices I have synced over, here's one that isn't syncing from MDM, I should note. This is a Linux device that I'm going to be using later. We can see that we're capturing several logs from these devices as they're doing these attestations. So the agent's reporting this information for the given device, the operating system, serial number. Device ID is the component we care about. This is the public key for that TPM, so that way we can do the attestations. And we can see 2 hours ago, while I was confirming that my POC was in order and just running through the flows, you can see this device did an attestation and successfully authenticated in a Smallstep. That it has access to the given resources that I've configured and are issuing certificates for the device and for, this is my Wi-Fi network, that are hardware bound and key protected. In this case, I'm using 90-day certificates. Historically, we recommend 24-hour certificates for a lot of things, but given these certificates are hardware bound, lifetime's a lot less important because they are stuck in the device and we can always revoke them if there is some sort of compromise, because active revocation is part of these authorities. That's great.
Right,
So
but
as
that
the
would be
device,
like if the device were stolen, right?
yeah,
Like you would need to do
exactly.
that. Yeah.
Yeah, or say
Because
for example, an employee was terminated
yeah,
and you can't get a hold
right.
of the laptop for some reason, you can just revoke the certificate, and then via active revocation, it's dead.
Yep.
No
That's great.
question. So that's great for device like inventory. That gets our certificates on the devices, but we also have a handful of protected resources that we can configure. So we're focusing on Wi-Fi today. We have other resources we can protect via device-attested certificates. For the demo today, I'm using Indomitable Human Spirit, which is my SSID of my network. You can see there's 9 devices assigned to this policy. And in here, I can specify a handful of things. Since I set it up as Wi-Fi, I mark that I don't have my own radius server. And so Smallstep went ahead and set this one up for me. So here's the authentication information I would need for my access point. And then when I set this up, I've also set up some assignment policy. So this can designate which devices get access to this Wi-Fi network. In this case, it is devices that are high assurance, meaning they have done a cryptographic attestation. They do ACME device attestation. We support a dozen different issuance protocols, but specifically, they have to have done an ACME attestation and they have to be one of three operating systems. So I can limit this to just one, I can limit this to more. Um, but this is where we're specifying assignment policy, client certificate details, and protection levels. So on the Smallstep side, this was everything I had to do. Number one, get my devices in a trust inventory. Number two, set up my protected resources and map them over. And now I can just use the given resources. So for Wi-Fi
I have a question,
authentication,
Hunter.
yeah, please.
What about users?
So when we pull the devices into the inventory, we also map them to a given user. So the user is coming over from MDM. In the case of my Linux device, I included the user when I uploaded it via the API. And then out of this, it registers as metadata on the given device. And so whatever metadata we have on the device, we can actually populate into the given certificates issued to it, which I guess I don't have anything in here, but I'm pulling it from these values for the actual credential. And so the device certificates that are issued here are actually for Hunter at smallstep.com having authenticated via the device.
Got it.
We also have device certificates that we issue out. So say that this is a shared device, or frankly, I don't care about the user. I just want to authenticate the device. We also push out device identity certificates, not even focusing on the user. And so we can break down certificates issued to a given user via the device credential, or we can just use the device credential itself.
That's great. Yeah, that's especially nice for Wi-Fi because in a lot of cases, devices need to join the Wi-Fi network before they even know what
Mm-hmm.
user is using them and stuff like that. Yeah.
Yeah, exactly. Or shared computers in like on a shop floor.
Hmm.
Um, okay. So in here, to set up my access point, I'm running Ubiquiti, Unify. I think it's a Dream Machine, which is pretty straightforward. I have two networks set up: Indomitable Human Spirit and Arbitrary Network Name. You can see currently nobody's connected to the former. It's set up with WPA3 Enterprise. Everybody is on Arbitrary Network Name. It's using WPA2 with a username and password that is shared amongst all my devices. So this is where I'm doing management from here. Going into Indomitable Human Spirit, all I had to do was enable WPA3 encryption and point it at a radius profile that I've configured. Dropping down to radius profiles. To set this up, I needed the IP address and the shared secret and port from Smallstep, my account here. And now my network is configured to trust this radius server and pass through authentication attempts to the radius server as a proxy. Carl, curious if I missed any key details in this flow.
Yeah, I mean, no, I think it looks great. So
So
what
the
happens
Wi-Fi
next?
setup. So now we just need to configure the devices.
Right.
So I have a MacBook Air in MDM in Jamf. And here I can just set up a configuration profile just like I would normally. Chances are you probably have something similar to this if you're running enterprise Wi-Fi, where you're pushing out certificates. This would probably say SCEP certificate or NDES in the case of like Intune, and then a network payload. The only difference here is we are using an ACME certificate payload instead of SCEP, where I was able to get the ACME directory URL from Smallstep as part of my Jamf integration. This is the key detail we need in Jamf to tell the clients what attestation authority to talk to. We're authenticating via the serial number, but then we also know that the device is attested and it is not extractable. The certificate payloads I'm pushing down are like root and intermediate of the signing authority and then root of the radius server. That way, to Carl's point, the clients need to trust the radius server that we're talking to. And then in the network payload, we edit it so we can actually see. I'm specifying the SSID of my network. I'd like to auto join. We are using WPA3 Enterprise with ETLS as opposed to PEEP, LEAP, etc.
Those are the
Um,
different types of EAP. There are other protocols for authenticating to enterprise networks, but EAP TLS is kind of the strongest one, right? That's the one that we use.
mhm. And then we're configuring the identity certificate to be the ACME credential that we're issuing as part of the configuration payload or configuration profile. And then trusted certificate, we're using Smallstep's radius, so I specify that here. And then I would just scope it out to my relevant devices. So let me add my MacBook Air to this. Switch computers real quick because I didn't have time to set up RDP yet.
Right. So these Jamf profiles, it's not just getting the client certificate down to the devices. It's also setting up the devices so that they trust the Radius server.
Good call out, Carl. So here I'm on my MacBook Air. You can see I'm connected to, well, I had this set up earlier. Let me switch back to arbitrary network name. That's kind of funny, actually. Oh, it's because I added the profile in Jamf, so it switched over to Indomitable Human Spirit.
There we go. It's just automatic.
That's kind of funny. Here, let me get rid of that now. Cancel. Kind of rare in a live demo where things connect quicker than I'm expecting them to.
Yeah, you can't show it connecting. I know. It's a
Yeah,
nice
that's
moment.
it's kind of
But
funny.
it happened. Well, you also showed that you didn't have any clients on this network before,
Yeah,
and
and here
now
I am now.
you have one.
Yeah. Yeah, let me get kicked off real quick, removing the device from that profile in Jamf. I'm going to do a sudo Jamf recon just to make sure that it's checking in appropriately, which it should be in the background. I just like to make sure.
So this goes and basically checks in with Jamf and pulls any updates. Is that right?
Exactly. Which it does automatically. This is just force pulling just to for the sake of time.
Yeah.
So I've removed it from the payload in Jamf. I'm on arbitrary network name now. It's letting me. If I try to connect to my other network, you see it's going to specify, like, ask me for a credential. So that's going to fail. Let me try with the other ones. Here's one that ships with my laptop. I'm not entirely sure what the other one is. Neither of them is the ACME credential that we were using earlier. Oh, I'm clicking around and you can't even see because it's dropped off the network. You can see it, it won't work. It just is not working.
Yeah.
So let me add it back to the scope in Jamf, pull down the profile, and you'll see it issue a credential and switch Wi-Fi networks. And there's that.
So normally it would go to Jamf like every 15 minutes or something and check in, but we're just
There we
making it
go.
happen right away.
Just swap Wi-Fi networks. This error came because it was trying to pull while it disconnected from the network.
Right.
Oh, sorry, my screen hasn't updated yet in that I'm sharing.
That's okay. I
Give it a second. There it goes. That's the fun part about demoing Wi-Fi when I don't
yeah.
have Ethernet ports plugged into my devices.
Yeah, exactly. Yep.
Um,
You're
or
actually
not.
disconnecting from the network. Yep.
Yeah,
So, okay, so there you are. You're on the EPTLS network now. Um,
and that's great. And I did this via MDM. This works in my
yeah.
existing flows. If I'm running in Jamf right now with SCEP certificates, I would just set up a Smallstep integration and swap out that SCEP certificate for an ACME one. Everything continues as planned, except now the certificates are bound to the device and the user can't pick them up and ship them if they so please.
Are you using 192-bit mode?
That's a great question. I don't know.
Okay. So 192-bit mode is like we call it NSA grade Wi-Fi because it's like I guess NSA, I'm probably gonna get this wrong, but I guess NSA like if you're going to access top secret information, this is what you need, is this 192-bit mode, which adds extra security, extra encryption um,
I
to
would assume
what is
so.
already very strong.
Yeah.
Um, and and yeah, that's optional, but it definitely works with our product. It works great. So,
So since we have time, and again, questions as they come up, please let us know. Um, get Zoom to stop telling
oh
me to
yeah,
start
Linux,
sharing. That'd be
nice.
great. Well, I figure because we have time, we have another, 9 or so minutes. What about devices that aren't in MDM or aren't supported via MDM? Chances are there's a handful of attendees today that have Linux devices in their fleets, managed how they will. Maybe it's with Fleet DM, maybe it's not. Um, Maybe you have 5 of them that you're trying to not support, and maybe there's a ton of developers that are really smart and expensive who want to run on Linux. So this is a great solution there because chances are most Linux setups aren't managed. Um, and so we have the Step Agent plugin designated for those particular workflows. So I have it here. This is what I ran earlier to do that attestation that we were looking at the logs for in the Smallstep dashboard. You would set this to run in the background when the device starts, but here I'll start it manually. You can see it's loading, making sure there's no old keys that are sitting around. There it does the attestation, and then you can see a certificate get issued. In the background, it's also going to configure WPA supplicant on the device to automatically switch me onto the correct Wi-Fi network.
Oh, look,
Easy,
you're already connected.
easy
Yeah.
peasy.
Wow. And so it just, and this would normally run in the background, but it just did, it kind of did everything.
Exactly. And I want to make a call out these errors or because it dropped off the network for a minute while it was still polling.
Got it.
So,
Yeah.
yeah, easy enough. There's a handful of helper commands in here. We can do a config. Oh,
Right. So with Linux devices,
excuse me.
because they're not an MDM, how do customers typically register their Linux devices with Smallstep and add them to the inventory?
Great
I think
question.
you covered this a little bit earlier, but I just wanted to.
So there's 2 approaches. One is a
Hmm.
user enrollment. We have that turned off by default. We recommend that if it is turned on, you require an additional approval step
So
because,
that's
yes, because that way just anybody can't just grab a new laptop and enroll it.
right.
Um,
And that's essentially like is it like they get an email and then they sign in or something? How does that work?
they would just run sudo step agent plugin. They'd install this off of our website and run register, and then their team name, which I'm not going to
Okay.
do so I don't clobber my configuration. You'd run this, it would route you through single sign on against your identity provider. And then, assuming
Oh,
it
cool.
authenticates, it becomes, I'm losing the word here, but like conditionally enrolled, waiting for you to actually
Hmm.
go in and approve the device. So,
Right.
the idea for this flow is say Carl drops his device in a lake and production suddenly has an outage. So he can run into the quickest Best Buy, grab a device, quickly grab the agent, install it, and call up IT department and say, "Hey, I'm Carl. Here's my device with this serial number. I need you to go in and approve this so I can get um, access to whatever resources, whether it be Wi-Fi or maybe in this scenario it's hardware mount credentials that give him access to like a cloud API
Hmm.
or SSH. If you have the ability to run scripts on the devices or you want your developers to do this, you can run sudo step agent plugin TPM to query the TPM information on the device. And here we can see the EKURI. If I just do dash dash fingerprint, It'll just pull that fingerprint. But when you're calling Smallstep's API to do a device registration, you would just need that value and then the user binding for the person that's on the device, assuming you want that person to have their username to land in the certificates. Benefit to that is the username then shows up in the radius logs for authentication. So
That's great.
ran this ahead of time. I enrolled it via the API in this case for this device. And then for the policy, when I set it up, I scoped it to Linux, and then this device just automatically received that configuration. Okay. And that concludes my demo. We did, just in summary, we went ahead and walked through device inventory. I pulled over some devices from MDM. I enrolled a Linux device via our API. The key data we need in there is the EK pub key for the TPM or the AK pub key for the case of like the Apple ecosystem. And from there, we were able to set up some protected resources, a radius configuration for a radius server. And from there, any of the devices that were scoped for that policy automatically just connected to the correct Wi-Fi network when they booted up.
That's great. Thanks so much for the demo. I think pretty much covers it, and we with what 3 minutes to spare here. So,
Well, I'm seeing some messages in QA. Oh, a little while ago too.
oh, all right, nice. Okay, let's cover
Let's
as
go
many
through
of these as we
these.
can in the last couple of minutes. Yeah.
Yeah, it is
Um,
recorded, by the way. It's going to go on YouTube. Um, as soon as we're done and Jen edits it. Let's see, starting at the top. Any known issues with, say, CTNA as well? No, really. Anything that supports mutual TLS as a form of authentication, we can slot in and plug in. The main challenges we run into every now and then is, say, the client we're integrating with requires like a PFX file, so P12 formatting. That becomes difficult because you're bundling to do that. You're bundling the certificate and key into the same file and setting it on disk. So you can't do Acme device attestation directly with a client like that. But we do have alternatives like derived credential flows where we can do an Acme credential and then a really short-lived bundled certificate derived off of that hardware bound credential. We don't like doing it, but our big thing is strongest possible assurance that your device connecting is that device. So that tends to be the only like limitation, but nothing we can't work around with what I believe to be a good compensating control.
that's great.
How does this
Oh
work with
yeah.
Intune provisioning? Yes, so it would need to be provisioned over a normal guest Wi-Fi. So it would be the same in terms of device enrollment to Smallstep. Um, sorry, my mind went blank as another question came in. Enrolled Smallstep, and then from there, they just have to get access to some Wi-Fi network somewhere in order for their device to kick off that attestation request to Smallstep. So we're not running into the AD joined requirements. You don't have to be on the local like network like you would with like autopilot, but you do need access to the internet in some capacity. So what
Yeah.
a lot of our customers do is they'll have a flow where if for some reason an employee is out of the office for 3 months on leave and then they come back and their certificate's expired, they just jump on the guest Wi-Fi network, does the attestation, and then boom, flips you back to the correct Wi-Fi network for actual work. Employee BYOD personal device authentication. Yeah, so regarding Trevor, regarding the employee BYOD and personal device authentication, that's the self-register flow that we were talking about. Um, Alternatively, you can query the TPM and report that to your IT department, but generally, yeah, the step agent register command would work cross-platform on any operating system type. Carl, please feel free to fill in my explanations here.
Yeah, I mean, you can set up the certificate trust any way you want as well, like use multiple networks if you want to. Um, but yeah, what Hunter is saying about BYOD, you just have to register You can register the device in and add it to the inventory if you want, or have a different. You can have a different setup with the CA if you want to, in terms of trust.
And then real
Um,
quick, I know we're at
cert
time showing
rotation.
the cert rotation flow.
Yes,
We have a couple different options. The one that demos the best is in the UI. So here's the ACME certificate for Wi-Fi that I issued 9 minutes ago on my Linux clients. So we have a full dashboard where you can pull certificates, you can query them, you can even download the public certificate if you really wanted to. But in here, we have a revocation flow where I can just go in and say, privilege withdrawn, this person was terminated, and I'd revoke the certificate, which I'm not going to do right now because I plan on using this device in a couple of minutes for another call. Um, and it would go ahead and lose access just like that. We also have a client flow where you can use our step clients to just pass the serial number for the certificate, authenticate to the authority, and then revoke it that way.
that's
We
great.
are, yeah. Any final questions? Again, I know we're running over a little bit, but if not, it's been great talking with everybody. Do we have API access to kick off via Azure or ticketing systems, etc.? It depends on the flow you're talking about. We do have a full REST API at gateway.smallstep.com that
Yeah, if you
covers.
check out our API. You can do a lot of stuff with it. And we continue to, our intent is to be API first. And so you can automate whatever you need to be able to automate here.
And we have a Terraform provider registered with Terraform if you so choose.
Cool. All right. Thanks everyone. Thanks for coming to the webinar today. Thank you, Hunter. Um,
Yeah, if
and
anybody's interested in talking to my team more about the stuff we demoed today, please reach out to us directly. Jen, I don't know if there's an actual email we like to route people towards for these types of things. Otherwise, I would say sales@smallstep.com.
It will be in the follow-up email.
Okay,
So
cool.
anyone who
that's
registered
great.
or attended, there will be a CTA to reach out with questions in the
Yep.
recording, of course.
All
Okay.
right.
Thanks,
Thanks,
Jen.
Jen, for
Thanks,
putting this
Carl.
together.
And thanks
Yeah.
everybody for joining. We will see you next month for whatever that topic will be. Jen, any sneak peeks? Have we settled on one yet?
Maybe on the holiday project. So stay tuned
We'll
for that.
see.
Ooh, that's always a fun one. Okay. Thanks, everybody.